Hey guys, I'm about to start the last tutorial that we're going to do on Admentum, which is interpreting conditional probability. I'm going to skip those first couple slides. What we're going to talk about in this tutorial is about the SAT. It says watch this video, but that really is just a link to the SAT site. You're welcome to go there and look at all the SAT info, but you don't need to. But what they do is they use statistical analysis of past scores to try to figure out if test scores are valid or not. So I got my knowledge article here. I'm not really going to look at it too much. Again, you're always welcome to read that. But we're just going to kind of get into this first activity here. Okay, and what we're going to do is use this College Board report. There's all kinds of info on here. And they specifically tell us to look at Table 5. So I'm going to scroll down. Here's Table 1, 2, 3, 4. Table 5, here's what I want. I'm going to zoom in a little bit just so I can see it a little bit better. And it has all kinds of data based on the critical reading, math, and writing test. Okay, so here what we're going to do in question number 1, we're going to find, given that the subject is female, what is the probability that a critical reading score is between 400 and 490? So this is given that this is a conditional probability, so we need to restrict the sample space. So we have to figure out how many total females there are. And I'm looking at critical reading, so I'm going to look at this data right here. Now what you could do is add up all of these females to see how many females to test, or you could scroll up a little bit, and it says right here how many females there are, 883,955. So that's going to be my denominator. Okay, but then I want to figure out how many of them were female and had that critical reading score between 400 and 490. Okay, and if you look here, there were 296,793 that had that critical reading score. You would put that in your handy dandy calculator and get 0.3357, which you could say is 33.57%. So yeah, 33.57% chance, given that you're female, that you're going to score between 400 and 490, okay, which is what they have here. Here we're going to do the same thing, but now we're looking at, given that the mathematics score is between 600 and 690, what's the probability that the subject is male? So now we're restricting it to just people who scored between 600 and 690 on math. So between 600 and 690 on math, that sample space is 296,518. That's my denominator. But now I want to know how many of those are male and scored that. So that's where we get that 162,564. And just a word of caution when you're doing these problems with lots of tables within tables, make sure you're looking at the right data, because the first time I did this, I was looking at the wrong data and my numbers weren't matching. So if you work that out, you get about a 54.82% chance if you score between 600 and 690 on the math of being male, which is what they got. Yay. Okay. And then finally, given that the subject is female, what is the probability that she will have a writing score of 200 to 290? So again, we're restricting it to the number of females, which is this 883,955 number. So it's going to be my denominator. And I want to see how many females had a writing score between 200 and 290. So it's 24,933. And then when you work that out, it's going to be 0.0282, which would be 2.82%. So, that's, the math itself is not too bad. It's just hard when there's so much data. They at least told us which table to look at. Okay, so if you give me 1 second, I meant to have this open beforehand, but I didn't. Come on to our notebook. We're going to review just how to find conditional probabilities, which are the probabilities when we say given that or if. So Smart Notebook is, of course, taking forever. So just as a review, if you want to find the probability of A given B, so like in that last example, the probability of a certain score given that you're a female or something, that will be the probability of A and B. And have I mentioned that I missed my smartboard over the probability of B? Okay, and that's what we were doing in that last activity. We were calculating all of that. Okay, so that's basically what this is saying here, breaking that down. Now we have a problem we got to work out. From the given data, calculate the probability that a student picked at random will have a height above 150 centimeters, given that the student is a girl. So given that there's a girl, that means I'm restricting it to just a sample space of the total number of girls, which is 44. And then I want them to be above 150 centimeters, so it would be 21 over 44. That's what you would work out. Okay, and if you put that in your handy dandy calculator, 21 over 44, you get 0.477. Okay. All right. So then now, this is basically just saying, like, if you look at this, a lot of that data, those are really big numbers, which is really easy to mess one of them up in your calculator and get an answer that's totally wrong. So this slide is basically just saying you can use percentages instead. Okay, so that's what we're going to do in this next activity. So you have to click on this. This is a spreadsheet. It's Excel, which I don't know if you can open on your Chromebook, but hey, you can look and see. Here's the table. I have it zoomed in so that we can see all the data. Notice this is percentages. So here, I want to look and see what is the probability that the critical reading score is between 400 and 490, given that they're female. Okay, so what I want to do is first of all figure out the total percentages of females, which if you look here in each of these total columns for female, it's 53.22. So I'm going to write that as 53.22. That's my denominator. And then I want to know what percentage of females had a critical reading score between 400 and 490, which is 17.68. So you're going to divide those two. When you divide them, you get 0.3322, which is the same thing as 33.22%. Okay, so let's submit that. And if we were to use data values, we would get the same thing. It might be a little bit different because of the rounding. Okay, but we can do the same thing here. And number two, what's the probability? Calculate the probability a subject is male, given that they have a math score between 500 and 590. So the math score between 500 and 590, that's 29.21% of people. So that's going to be my denominator. But then the number of those that were males that had that score is 13.93%. So I'm going to do 13.93%. And when I divide those, I'm going to get 0.769, which is 47.69. That's the chance that you are a male, given that you had between 500 and 590. Okay. And then finally here, calculate the probability that you got between 700 and 800 on the writing score, given that you're male. So the total percentage for male, you notice, is 46.79. So it's going to be my denominator. And then the percent of people that had a score between 700 and 800 on writing and were male, 1.88%. So that's what you would divide. And when you do that, you 0.0402, which is 4.02%. And we can double check here that that is correct. Okay, so it's just saying, like, hey, if the data is in percentages, you can still basically do the same thing. And that's what this slide is saying here as well. Here we have a table. I don't know why it shows up with the answer, that's weird. But anyway, calculate the probability a ball picked at random will be green, given that the ball is striped. So here, the ball is striped, that's a 60% chance. So that's going to be my denominator. And that it's green will be 26.5. So 26.5% divided by 60%. When you do that, you get 0.4422. And you can see that work right down here. That's how you would do that. It works the same thing with percentages. Okay. Now we're going to go back to this knowledge article, because this is another way that we can calculate conditional probability with something called Bayes' theorem. I'm going to be perfectly honest with you. I wouldn't recommend you use it very often. But I am going to write it over here, just in case you want it. Okay, so Bayes' theorem says that the probability of A given B is equivalent to the probability of B given A times the probability of A over the probability of B. Okay, so this is Bayes' theorem. Now, I don't know about you, but that seems like an awful lot more work to calculate because you have to calculate these three separate probabilities, and that's a pain. So we're actually not going to really do that too much because this next one is an activity, and it's still using that table 5. And so I'm going to actually go down to look at question number 3. It says, using Bayes' theorem, calculate the probability that a subject has a critical reading score between 700 and 800, given that they're male. Okay, so just to save us time, we're going to say that A is having a critical reading score between 700 and 800. B is the subject being male. So you have to calculate all of these independent probabilities. And part of the reason that I don't want to do this is because these numbers here don't actually match the table. Like if we look at the probability of you getting between 700 and 800 on the critical reading, so here they have 79,049. Here they have 76,565. So the numbers are all off anyway, and I don't want to confuse you. But basically, you calculate those three different probabilities and you put them in the formula, you plug and chug, and you get that is 4.99%. Okay? Again, that's a lot of work. I really don't want you to do that for those problems when we could have just calculated them the old way. Now, this problem is a little bit different. This one we would have to do Bayes' theorem. So what it says is that the probability that a diner sells a milkshake is 0.63%. So I'm going to kind of minimize both of these and see if I can write this out. Okay. So I'm going to let A be the probability that they sell a milkshake. That's a shake. I'm going to let B be the probability or the event that it's strawberry. Okay. So if we want to work this out, what we would have to do is find the probability, first of all, of A. So find the probability of A, which is the probability that you will sell a milkshake. They say this is 0.63. Then we want to find the probability of B, which is the probability that something is strawberry flavored, which if you read that right there, that says 0.576. But then if we're going to use Bayes' theorem, we also have to find probability of B given A. So the probability of B given A is the probability that something is strawberry flavored given that it's a milkshake, and they give you that is 0.546. Okay, and now we want to find the probability that it's a milkshake, that they sell a milkshake given that it's strawberry flavored. So if we go back to Bayes' theorem, which is way up here, this means that we will have to do I don't want to do that. It would have to be the probability of B given A, which is 0.546, times the probability of A, which is 0.63, over the probability of B, which is 0.576. And so this is what you would have to type in your calculator. And when you do that, let me just double check that everything is right here. You get 0.597. Okay. And so this is an example of when you would have to do Bayes' formula. Okay. And this is just saying like, hey, you could have done it the other way, which is way easier. So my advice is don't use Bayes' formula unless you have to. And again, on this activity, this is wanting you to validate Bayes' formula, which is looking down here. We're just going to look at question 1 because this matches question 3 of that last activity, where we said that if they had a critical reading score between 700 and 800, given that they were male, the probability was 4.99%. So if you wanted to validate this, you would just have to work it out by hand, figuring out the percentage that they're male, or the number of males. And if you remember the number of males, you could look up at this table, 776092. Then you want to find the number of males between 700 and 800. But remember I said that the numbers were a little messed up here. So what test are we looking at? Critical reading. On the table here, it says 40,151. But if we check our work down here, it says 38,000. So somewhere along the lines, the numbers got mixed up. But just notice that when they did that, they got the same percentage, whether you use Bayes' formula or not. So in question number 2, is Bayes' formula necessary? No. The only time you would have to do it is if you only knew probability of B given A, probability of A, and probability of B, like in that milkshake example. Okay. And I think we have one more milkshake example question to answer. So I'm going to get a new slide here. Here they say that the probability of diner sells a milkshake given that it's strawberry is 0.597. So I'm going to call that the probability of A given B. Okay, and they say the probability of a milkshake is 0.63, so I'm going to call that the probability of A. And then the probability that they sell a strawberry flavored item given that it's a milkshake, so that's going to be the probability of B given A. It is, what was the percentage? 0.546. So this is similar to that last problem, but not exactly the same, because now what they want to know is what's the probability just that a food is strawberry flavor, which would be, we want to know the probability of B. Okay, so this is a case when you'd have to use Bayes' theorem. If we use our setup is actually going to look like this. The probability of A given B equals the probability of B given A, so 0.546 times the probability of A, which is 0.63, over the probability of B, which I don't actually know. So what I would do is I would multiply by the probability of B and then divide by 0.597. Work that out in your handy dandy calculator, and when you do that, you end up getting 0.576. That's a 7. Okay. So that's an example of when you'd have to use Bayes' theorem. All right, so here's our summary. Here's our gold star, and hey, good news. That is the last Edmonton thing that we're going to do, because then we're going to switch on to Delta Math, which I know is a little bit easier for all of us. All right, let me know if you have any questions.